Hey kiddos, welcome to this week's homework review. If you have any questions outside of this, please go ahead and remember that you can always send them to me. This year, the work is tough. If you are feeling stuck, remember that there are a lot of supports in the classroom. Highly recommend using them. Let's go ahead and get started. So we're looking at rational versus irrational here. If we're looking at this first number, is it going to be rational or irrational? It's going to be rational because we can see that we have 0.743, and then that number is going to repeat. Because it is repeating, it is going to be rational. Our second number, the square root of 36 plus 3. Square root of 36 plus 3 would be the square root of 39, which is going to be between 6 and 7. This is going to be irrational. Again, between the square root of 39 is going to be between 6 and 7. If we look at it as a decimal, it's actually going to be 6.2449, making it irrational. Looking at the rational numbers, this is repeating. This is a perfect square. The answer is 4. This is already as a fraction. This one is going to be irrational because you can see the dots are telling us that this is going to continue. Over here, irrational, irrational, and these are both going to be rational because we have repeating and we have as a fraction. What is the estimated value of the square root of 47 to the nearest whole number? So if we're thinking about 47, 6 squared is going to be the answer to 36. 49 is going to be 7. So 47 is going to be between 6 and 7, rounded to the nearest whole. It's going to be closest to 7. Is the square root of 31 plus 3 a rational or irrational number? So since we have these separated, first of all, we're looking at the square root of 31, getting that answer, and then adding it to 3. I want to point out that that's different than this one where everything is within the square root. So since the square root of 31 is irrational, the whole thing is going to be irrational. 31 is not a perfect square, so it doesn't matter what it is. When we add it to whole number 3, it's going to stay irrational. Between which two whole numbers is the square root of 51? We're going to be between 49, which is 7 times 7, and 64, which is 8 times 8. So it's going to be between whole number 7 and whole number 8. Is the square root of 14 rational or irrational? Square root of 14 is going to be irrational because as a decimal, it does not end or terminate, and it does not repeat. So that's going to be irrational. Last two on this page. What is the definition of an irrational number? This is a number that never terminates or ends and never repeats. So you cannot write this as a fraction or the quotient of two integers, which is just a fancy way of saying fractions. So not a fraction. On the other hand, irrational numbers, they terminate, which means end or repeat. So do they in decimal form terminate or repeat? Either. They can terminate or they can repeat. If you have questions on these, don't hesitate to reach out. If you have trouble looking for your notes in the classroom, please let me know. All right, if you're still here, it means you're ready for page number 2. There is a great support in the classroom for this if you were having trouble. We're looking for changing these to a decimal. How are we converting these fractions to decimals and our decimals to fractions? So these with our repeating decimals, these, I'm going to circle them. We are going to go over them. But these are the ones that have a support in the classroom. Those are the ones that we don't bring background knowledge in for. 2/9, 13/11, the ones that are just fractions going to decimals. You can do that with division. So let's start here. I want to break them apart by type. 2/9 is the same as 2 divided by 9. Add your zeros, you're going to need them. Decimal goes up. 9 does not go into 2, but it goes into 22 times. 2 times 9 is 18. We subtract for 2. 9 goes into 20 again, 2 times. 18, at this point, we can see the pattern. It's going to be a repeating decimal. Again, we're going to come back to these. I want to do them all at the same time. 13 divided by 11. Since the bigger number is inside, We are going to have a whole number here. 11 does go into 13 once. 11 does go into 20 once. When we subtract here, we get a 9. 11 does go into 90 8 times. And this is going to continue. I'm sorry, 88. It's going to be 2. And then we're going to get back to this pattern. So this 18, 1800ths is going to be repeating. So 1 and 1800ths repeating. Coming down here, 34 divided by 99. Again, this one you should have the background knowledge for. 99 does not go into 3, does not go into 34, does go into 343 times. 3 times 99 is 297. When we subtract with our borrowing, we end up with 43. Bring down our 0, goes in 4 times, which is 396. At this point, when we subtract, we're going to see that it's going to keep repeating. We go back to this pattern. And then we have 2 more, 2 more down here that we have background knowledge for. Top number inside, bottom number outside. So this one, depending on how far you got, it is going to go in 7 times, which is 49. 7 goes into 10 1 time, which is 3. If you brought this out and you divide it, this is actually going to be a repeating decimal. Do I think that all of you divided it out to 6 places? Probably not. But if you did, the 714285 is going to be the repetition. Once you get through and you do that last part of 40 minus 35, you're going to get a 5, and it's going to bring you back up to that portion. It does repeat. Last one for this style. And then again, we're going to look at the other style. I wanted to separate them. 12 goes into 19 1 time. Brings down a 7. 12 goes into 75 times. Brings down a 10. 12 goes into 100. And we're going to get down here. We're going to have a 4. And it's going to repeat on the 3 portion, okay? Let's come back up to the troublemakers. And I'm actually going to clear these so that we have enough space, but you can always go back to, oh, it doesn't want to let me do it. You can always go back in the video if you need to see them again, but I'm going to need your space. So there is a principle in the classroom that supports how we make a decimal into a fraction when we have a repeating component. And there is a beautiful notes page that talks about it and how we figure that out, because these are not as easy to just go ahead and transfer over. So what we're going to do is we're going to set it up as out of 100. And that's going to be equal to 68.8, moving that decimal over twice. We're going to subtract 10x from this side and 6 8/10. We end up with 90x is equal to 62. Divide by 90, we get that x is equal to 62/90, or you can simplify it to 31/45. Again, this formula is in that principle. I highly suggest that you take a look at it if you need some help. But just as some reminders and some refreshers, we needed to move this decimal over twice to get to the repetition, those 2 spaces, and then subtracting and moving forward. Taking a peek over here, I have 5/10 repeating, which means 0.555. If I move it over 1 space, I get 5.5. So that's where my 10x comes from. Get rid of one of my x's. I end up with 9x is equal to 5. Divide both sides by 9. X is equal to 5/9. Coming down here, we have 1200ths. I would have to move it over 2 spaces to get to the repetition. So 100x for those 2 spaces to get me to 12.12. If I subtract 1x and my 1200ths, which is 1 repetition, I get 99x is equal to 12. Divide both sides by 99. I get 12/99ths. If you simplified it to 4/33, you are on the right track. Either of those is fine. Again, this formula is outlined in those notes pages. I do not expect you to remember it. Having those things available to you is really helpful. All right, how many times would I have to move it over to get to the repetition? Twice. So that's going to be 100x is equal to 143.3. Only the 3 is repeating here. I'm going to get rid of 10x. And I'm going to get rid of 14.3. I have 90x is equal to 129. Divide both sides by 90. X is 129 over 90. We can simplify this to 43 over 30, or 1 and 13/30. If you got here, though, I love it. If you're not simplifying all the way down, I get it. This is a lot. Over here, I have to move it once to get my repetition. So 10x is equal to 2.2. I'm going to get my whole number. So if I subtract 1x, I have 9x is equal to 2. Divide both sides by 9. X is equal to 2/9. You don't need to simplify this at all. And that is the end of this page. If you have trouble with these, I get it. They're a lot. Bring your questions to class. We are going to continue to practice them. But please make sure that you have that support page. You don't have to print it. Go ahead and save it. It's going to be really helpful. All right, last piece was 2 pieces broken down, some exit tickets. I asked you to arrange these by irrational, rational, whole number, and integer. And as a reminder up top, they can be in more than one category. So irrational is pi over 6 and the square root of 30. Neither of them meet that rule of being a terminating or repeating decimal. Rational, all of the other ones. So negative 6.25, 4500ths because it repeats. 2.5, it's in a fraction form. Whole number 14. 900 or thousands, 3300ths. Negative 7 and 4.6. So again, everything else. Whole numbers, 14. Integers, 14 and negative 7. And then the last piece down here was doing some more converting. This would be 7 divided by 11. Add your decimals. 11 does not go into 7, but it does go into 76 times, which is 66. When we subtract for 4, bring down our 0. 11 goes in 3 more times. We get a 7. This is going to repeat. That brings us back up to this spot. If we're converting 8/10 to a fraction, I need to move this over once to get to the repetition. If I subtract an x, I end up with 9x is equal to 8. Divide both sides by 9. X is equal to 8/9. Down here, converting to a fraction, I need to move it over twice to get past the repetition. So 100x is equal to 22.22. If I subtract an x and my repetition, I get 99x is equal to 22. Divide both sides by 99. X is equal to 22 over 99. Simplified, it's equal to 2/9. And then the last one, this one is 5 divided by 13. If we do the division, I'm going to run out of space. It's going to go in 8 more times, which is 104. Bring down to 0. It's going to be 4 times. This is going to repeat. Again, it just depends on how far you went out. If you went out 6 decimal places, it repeats. If you didn't, I completely understand. We never go out that far. If you have questions on these, please don't hesitate to bring them to class. Go work.